So we are now on day 6. We are moving on from two-dimensional objects to three-dimensional objects. And just like the first day of 2D, today's focus is just going to be on understanding the pieces of the formula so that we can apply the formulas to any given situation. So three-dimensional objects are formed by rotating two-dimensional objects around a line. So if I look here, I have a triangle, and we want to guess what three-dimensional object is going to be formed if I spin that around the line. So I sent you the Word document today, so you can go ahead and click on this link. You can right-click it to open the hyperlink, and it'll bring you to an animation of it. But if I look at this, remember, I'm going to spin this around. I'm spinning this around. As I spin this around the whole object, remember however far this is, that's how far it is on the other side. I see that what I'm going to do is I'm going to form a cone. So that's where our three-dimensional objects come from, spinning the two-dimensional objects around a line. So we have surface area and volume. Those are the different kinds of formulas we're going to talk about. And when we talk about these, we kind of have 3 categories for each of them. We have prisms and cylinders. These all go together because prisms and cylinders have a consistent shape the entire way. So if I look down here, this right here is a cylinder. A cylinder has a circular base, and it keeps that shape the whole height of the object. Now, this is an example of one kind of prism. This is a pentagonal prism because the base is a pentagon. Now, in a prism, the base is the non-rectangular side. So if I look over here, this is a rectangle. So it's sitting on the bottom, but the bottom isn't necessarily the base. The base is the non-rectangular side unless it's a rectangular prism. For example, this right here is a rectangular prism. Every single side of that shape is a rectangle. So we put the prisms and the cylinders together because it has this consistent shape the whole way through. The lateral area is the area around the shape. So think about a toilet paper roll. A toilet paper roll is hollow and it has open bases. That is the lateral area. The perimeter, or the big P stands for the perimeter of the base. So again, in a cylinder, the base is a circle, and a prism, the base is the non-rectangular side. This H is coming from the prism cylinder formula, so this is going to be the height of the prism or cylinder. Now the only difference between lateral area and total area is the bases. And in both a cylinder and a prism, it will have 2 bases. So again, think about a toilet paper roll. It's normally hollow, but if I were to close off the top and close off the bottom, that's my total area. And there are 2 of them. There's a top and a bottom. Here's my first base, and here's my second base. That's why we have 2 big B's. Big B stands for the area of the base. Now this is going to be different every time. This is going to bring you back to day 1, all of the area formulas, because you can see here In the cylinder, your base is a circle, so pi r squared would be the base area. Here, this is a pentagon. You don't know how to find the area of a pentagon. But if it was a triangular base, if it was a square base, whatever your base shape is, that's what you do for a big B. Now the next category is pyramids and cones. The reason why pyramids and cones go together, they use the same formulas, is because they're not consistent with their shapes. The way our cylinders and our prisms work, we see that we have the base of my period, and it comes the pyramid, and it tapers up to a point. So it doesn't have that consistent shape the whole way. Same thing is true for your cone. I have a circular base like I do for a cylinder, but it's not consistent. It tapers to a point. So unlike the prism and the cylinder, pyramids and cones don't have a consistent shape the entire height. They taper off. And this is going to give us a little bit of extra information. So P is still the same. So P is the perimeter of the base. Important there. Identify the base and then do the perimeter of the base. Just a note that if you have the perimeter of a circle, that is the circumference, which is on the first review, which is 2 times pi times r. So when you have a cone or a cylinder, when you're looking for the perimeter of the base, you're looking for the circumference of a circle. And then our new letter here is this cursive L. This is going to be your slant height. This is going to be a little strange in the pyramid. It's easier in the cone. The cone, it's the slanted height. It's the one that's not perpendicular. Really easy, no confusion. Now in the pyramid, we see that this is the slant height. It is the height of the triangular face. Sometimes it gets confused and you want to say that this right here is the slant height. That is a no-go. Yes, it is a slanted height, but it is not the slant height. The slant height is the height of the triangular face. And again, the lateral area is an open shape. So to create the total surface area, all we're doing is we're taking that lateral area and we're adding a base. With cylinders and prisms, we added 2 bases because they had a top and a bottom. But notice in your pyramid, you have 1 base. In your cylinder, you only have 1 base because remember, both of those objects taper to a point. So big B stands for base area. Then we have the volumes of those cylinders. Big B is always going to be the same thing. So big B again stands for base area. H is always height. But we have lots of different kinds of heights. Is it the height of the base? Is it the height of the prism? We know it's the height of whatever formula you're looking at. So since we're in the prism cylinder formula, this is going to be the height of the prism / cylinder. Because the pyramid and the cone taper, it's going to be 1/3 times base area times height. And again, that's height of the pyramid or the cone. Now our third category is the sphere, our 3-dimensional circle. And for our sphere, our 3-dimensional circle, if we look at our 2 formulas, the only thing we need is the radius value. R stands for radius. If you know the radius, you plug it in and you are good to go. Just remember the difference between exact answers will have pi. Rounded answers, you put pi into your calculator, and you find out what it rounds to. So the surface area is 4 times pi times radius squared. The sphere volume is 4/3 times pi times radius cubed. Squared for area, cubed for volume. If you look down here at the bottom, just like at the top, you'll see that there's several different links here. There's a link to find some more explanations, some videos explaining the volume and the area formulas. Again, I sent you the Word document, so you can go ahead and right-click and open hyperlinks for those. Last, we have one example of applying these formulas. So just like with before with the two-dimensional, the first thing we do is we identify our shape. So in this case, we see that we have a pyramid. I go to my pyramid formulas. For total surface area, this is 1/2 big P, which stands for perimeter of the base, times the slant height plus the base area. Look here, first we need, it looks like this got cut off. This is 8. The perimeter of my base, this is a square base, so this is 8. This is 8. Remember, perimeter is distance around. So I've got 8 plus 8 plus 8 plus 8, or 8 times 4, to find that my perimeter is going to be 32. The slant height, that's what that cursive L here is. The slant height is the height of the triangular face. So my slant height is 5. And the last part here is going to be big B. Big B is your base area. Remember, the base here is that square, that rectangle. So it's base times height, giving me 64. I plug all of that in. So 1/2 perimeter we found, which was 32. Slant height, which we found was 5, plus the base area of 64. If you want, just go ahead and put all of this into your calculator at once. If you don't, you need to simplify these three numbers together. So 1/2 times 32 times 5, which gives you 80. Then add the 64 to get that the total area is 144 feet squared. But again, you can just enter it from here all in your calculator. Now that was total surface area. We still have this perimeter, but we want the volume this time. So again, we look at our formula sheet, we look at the volume for a pyramid, which is 1/3 base area times height. Big B, that is again base area, which we found that the base area already is 64. Now this right here, this H, is the height of the pyramid. So the height from the base to the top, that is this height right here. Not the height of the triangular face, but the height of the actual pyramid, which is going to be 3. So 1/3 times 64 times 3 leaves us with a total volume of 64 feet cubed. Remember, area is 2-dimensional, volume is 3-dimensional. So area is feet squared, volume is feet cubed. All right, so that is our intro to our surface area and volume formulas for 3-dimensional objects.